Building scalable system isn't just about writing good code. It's about anticipating and solving problems before they become critical. Today, we'll explore 8 system design challenges that every growing system faces, along with the solutions that top companies use to tackle them. Every successful application eventually faces the challenge of handling high read volumes. Imagine a popular news website where millions of readers view articles, but only a small team of editors publishes new content. The mismatch between reads and writes creates an interesting scaling problem. The solution is caching. By implementing a fast cache layer, the system first checks for data there before hitting the slower database. While this dramatically reduces database load, caching has its challenges, keeping the cache in sync with the database and managing cache expiration. Strategies like TTL on keys or write-through caching can help maintain consistency. Tools like Redis and Memcache make implementing this pattern easier. Caching is especially effective for read-heavy, low-churn data, like static pages or product listings. Some systems face the opposite challenge, handling massive amounts of incoming writes. Consider a logging system processing millions of events per second, or a social media platform managing real-time user interactions. These systems need different optimization strategies. We tackle this with 2 approaches. First, asynchronous writes with message queues and worker processes. Instead of processing writes immediately, the system queues them for background handling. This gives user instant feedback while the heavy processing happens in the background. Second, we use LSM tree-based databases like Cassandra. These databases collect writes in memory and periodically flush them to disk as sorted files. To maintain performance, they perform compaction, merging files to reduce the number of lookups required during reads. This makes writes very fast, but reads become slower as they may need to check multiple files. Handling high write loads is just one part of the puzzle. Even the fastest system becomes useless if it goes down. An e-commerce platform with a single database server stops entirely on failure. No searches, no purchases, no revenue. We solve this through redundancy and failover, implementing database replication with primary and replica instances. While this increases availability, it introduces complexity in consistency management. We might choose synchronous replication to prevent data loss and accept higher latency, or opt for asynchronous replication that offers better performance but risks slight data loss during failures. Some systems even use quorum-based replication to balance consistency and availability. Critical services like payment systems need true high availability. This requires both load balancing and replication working together. Load balancers distribute traffic across server clusters and reroute around failures. For databases, a primary replica setup is standard. The primary handles write, while multiple replicas handles reads, and failover ensures a replica can take over if the primary fails. Multiple primary replication is another option for distributing write geographically, though it comes with more complex consistency trade-offs. Performance becomes even more critical when serving users globally. Users in Australia shouldn't wait for content to load from servers in Europe. CDN solved this by caching content closer to users, dramatically reducing latency. Static content, like videos and images, works perfectly with CDNs. For dynamic content, solutions like cache computing can complement CDN caching. Different types of content need different cache control headers, longer duration for media files, shorter for user profiles. Managing large amounts of data brings its own challenges. Modern platforms use 2 types of storage, block storage and object storage. Block storage with its low latency and high IOPS is ideal for databases and frequently accessed small files. Object storage, on the other hand, costs less and is designed to handle large static files, like videos and backups at scale. Most platforms combine these. User data goes into block storage, while media files are stored in object storage. With all these systems running, we need to monitor their performance. Modern monitoring tools like Prometheus collect logs and metrics, while Grafana provides visualization. Distributed tracing tools like OpenTelemetry help debug performance bottlenecks across components. At scale, managing this flood of data is challenging. The key is to sample routine events, keep detailed logs for critical operations, and set up alerts that trigger only for real problems. One of the most common issue monitoring reveals is slow database queries. Indexing is the first line of defense. Without indexes, the database scans every record to find what it needs. With indexes, it can quickly jump to the right data. Composite indexes for multi-column queries can further optimize performance. But every index slows down writes slightly since they need to be updated for data changes. Sometimes, indexing alone isn't enough. As a last resort, consider sharding, splitting the database across multiple machines, using strategies like range-based or hash-based distribution. While sharding can scale the system significantly, it adds substantial complexity and can be challenging to reverse. Tools like Vitess simplify sharding for databases like MySQL, but it's a strategy to use sparingly and only when absolutely necessary. If you like our videos, you might like our system design newsletter as well. It covers topics and trends in large-scale system design, trusted by 1 million readers. Subscribe at blog.bytebygocom